Hi everyone, this is Dr.R.Alarmelu Mangai, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So in this video series, we are going to see the topics related to theory of computation. So in this video, we are going to discuss under the first unit, Introduction to Theory of Computation, which comes under finite automata. So now, what do you mean by theory of computation? So, it is nothing but this theory helps the computer in deciding whether it can compute a problem or not, whether it is possible to compute a problem or not. Computation is nothing but what? Computing something, that is calculating something. So if a problem is given to the computer, this theory helps or analyzes whether the computer can solve that problem or not. So the theory of computation is a branch of computer science and mathematics that explores what computers can do and cannot do. It deals with a problem that can be solved using algorithms and those that cannot. An algorithm is a step-by-step process that a computer follows to solve a problem. The theory helps us understand the limits of what can be computed, no matter how powerful a computer might be. Next one is, what are all the overviews we are going to see is, what can be computed, how efficiently can it be computed, different models of computation, languages and grammars, complexity and decidability. So what can be computed? So here the problem which the computer can solve, that the system has to decide. So the theory studies which problems can be solved with the computer or which problems are beyond the reach of any computation. So it has to first find out whether that problem can be solved. Next one is how effectively or efficiently it can be computed. So we have heard about the term performance. So what is performance? How fast a problem can be solved. So it also looks at how efficiently problem can be solved. For example, it examines how fast an algorithm runs or how much memory it uses. So it has to use a short storage and it has to compute in a short duration of time. Then different models of computation. So we have got three different models. One is finite automata, other one is Turing machine, finally regular expressions. So what is this finite automata? It is a simple machine that process sequence of inputs to decide if they belong to a particular set or not. And then next is Turing machines. This is more powerful theoretical machine that can simulate any computer algorithm. They help us to understand the limits of what can be computed. So it will find out the limit of the problems what can be computed. And next one is regular expressions, tools for describing patterns in texts which are closely related to finite automata. Next one is languages and grammars. So what do you mean by that? We have different languages and each and every language will use a grammar. What is a grammar? That is the rules to be followed. So the theory also involves studying formal languages and grammars, which are the ways to describe the structure of the language that the computers can process. This is not related to the software languages. Okay, so this we will discuss later in detail. Next one is complexability and decidability. So it investigates which problems are computationally feasible, which can be easily done, and how their complexity affects their solvability. So it finds out whether this complexity of the problem finds difficult in solving that particular problem. So next is coming to the assignment part. You have to study the overview of theory of computation, what we have discussed before, that is how it can be computed and what can be computed and how effectively it can be computed, all those things, and different process models. All these things you have to learn, and we have referenced this link, and in the next class we are going to discuss about basic terminologies of finite automata. Thank you.